So hello everybody, thank you for attending our talk about achieving hyperproductivity with PCF and microservices. Let's just quickly introduce ourselves and then we just jump right into the middle of it. My name is Thomas Seibert. I am the lead architect of Mercedes-Benz I/O. I would like to show you a picture of me, but
it doesn't work.
It doesn't work at the moment. Okay, so yeah. Now that's me on the left. I'm the lead architect of Mercedes-Benz I/O.
And yeah, my name is Gregor Zurowski. I'm a software architect. I work in Thomas's team. I'm also an official Apache committer for Apache Camel. I'm also a PMC member at Apache Camel. And if time allows, I sometimes do technical editing for Manning.
Okay, that's who we are. Now, what do we do? And probably it's just the distance. Let me just see here. What do we do? So basically, Mercedes-Benz I/O is responsible for Mercedes-Benz on the web, at least in most of the European or all the European markets or countries and also the South Pacific countries. We have end consumer orientation in mind. So basically, we deliver or provide information to the end consumer with regards to everything which is Mercedes-Benz related. So if you're interested in a vehicle of Mercedes-Benz, then you can go to Mercedes-Benz DE for Germany, Mercedes-Benz FR for France and other 56 countries and just get the information you want. You can also get information about comparing motorization of the vehicles. You can configure your dream car. And if you want to book a test drive because you're really interested in purchasing a Mercedes-Benz, then you can book the a car via test drive. So, well, you see that the title of our presentation is Achieving Hyperproductivity. So what we think is really important to know or to define is what really productivity means. And then back in the days in the 90s, productivity was simply the output versus the input. And the output was measured in the 90s with lines of code. That's a very bad idea as we know by today. And we continued to measure it and have apply better measurement techniques. So once then lines of code was not valid any longer, so we reverted to function point analysis. Also a very bad idea. Sometimes output was also measured in the working time or the working overtime, also a bad idea. And on the input side, we had the cost. So basically in those times, the IT department has been seen as a cost center and not as the engine of competitive advantage or value creation. This was the old world. Right now, we're not living in the old world any longer. We live in the new world, and we discussed what kind of productivity really we want to achieve or long for. And we knew that output was not enough. So we thought whether outcome might be the better term, but finally we agreed upon the impact on customer behavior as the output or replacement of the old term output, and the resource binding as a replacement for the input. So impact also is, well, not really easy to understand, but we knew that customer value, if we create true customer value, then the impact will follow. And this is something to keep in mind when I go to the other slides in the following. So where do we allocate resources? This is the input side, and this is also something where we don't ask ourselves how much input we need to have, but also where to allocate it, because if you bind your resources in one place, you're not able to use it in another place. So calculating the cost of delay is a very important and very helpful factor as well. So, well, anyway, if you recall the title, we didn't talk about productivity, we talked about hyperproductivity. What do we mean with hyperproductivity? Hyper is a word coming from the ancient Greek, and it means over or above. So basically what we think is we ask ourselves, can we agree a new level of productivity? For example, if the cloud came into being, there was some kind of disruptiveness where we reached a new level of productivity. And so, well, to reach the new level of productivity, you have to change the rules, or you have to change the game. Some of you probably know about the 10K developer or 10K programmer or the 10K development team. This means that some teams are 10 times as productive as regular teams. I don't think that this is the right approach, but anyway, we need to know that we need to know how we can reach another level. And this is probably best explained with a car. You sit in a car, you push the gas harder and harder and harder until the engine explodes or overheats or whatever. But you also could change the gear. This means changing the rules. So you apply something which probably is right new and quite disruptive, and with that, and only with that, you will be able to achieve hyperproductivity. Of course, in order to change the game or in order to change the rules, you need to know and you need to understand your processes. So this is where systems thinking comes into place. And there are some kind of techniques, for example, value stream mapping. If you have your processes and you have many steps in your process, you have to identify and analyze each and every process step, and you have to think about whether this process step really creates value or not. Sometimes it creates value, all fine, you go ahead to another process, and this process, the other process step, might not create value, but it might be necessary. So you have to minimize the effort, and sometimes you see or identify process steps which don't create value, and they're not necessary, so you have to eliminate them. And then we come to bottlenecks. So what I always say is that the most powerful enemy of productivity or hyperproductivity is the bottleneck. Because, according to the theory of constraints, if you improve something in front of the bottleneck, you just push harder, you increase the pressure on the bottleneck, so this doesn't help anything. And if you improve something after the bottleneck, it has almost no effect. But how do we measure impact? So this is really important because, according to Peter Drucker, you cannot improve what you cannot measure, or you cannot manage what you cannot measure. So we need to find ways how to measure the impact or the value which we create for the customer. And this is done by what we call hypothesis-driven, or not only we, but what we also call hypothesis-driven development. So whenever a component or a product or a new feature will be rolled out, we first have a hypothesis. This is the starting point of a component or a feature or product. And then we have KPIs, for example. We use the lean canvas model in order to fix what we expect from this component as a value add. And of course, it's very, very important with KPIs that they need to be actionable. So if you define KPIs, it's really important that you can act upon them. If you cannot act upon them, they're called vanity metrics. So if you have KPIs which are not under your control and you cannot change those KPIs or those metrics, then they're not actionable and they're useless. So I talked about process steps and eliminating or identifying and eliminating waste. Probably you've all heard about the 7 wastes of software development. This is something which was made popular by Mary and Tom Poppendick in their book. I think it was published 2003 in the book Lean Software Development. And those are basically the 7 wastes of software development. Well, many of those, or some of those, of course, cannot be removed by using PCF or microservices. But we thought about what of those 7 wastes can be removed or minimized by using PCF and microservices. And those were the ones which we identified. Partially done work. If you build a monolith, this might take weeks, months, or even years. And during those building, when the features are not rolled out to the customer, there are no customer value because the customer doesn't see them. It's not visible for the customer. And this is partially done work. If you do microservices, then you have probably 2 or 3 weeks or 1 month. You roll out the feature, it creates customer value or it doesn't, but it's not partially done work. And the handoffs, delays, and defects are things which we can minimize or avoid by using PCF, because we concentrate on the application logic, on the value creation towards the customer, and all things like service binding, resources, configuring servers. This is done or abstracted away by PCF, and Gregor later on will go into details about that, how we minimize this. Sometimes people think that higher productivity means higher speed, and this is only partially true. So speed is nothing without control. What we call the better metric is approximation velocity. This means how fast are you approaching your target. Let me explain this with 3 figures. Here we have a target, and those are small errors, so you have a low development velocity, and you don't adjust your direction. So you move slowly, but you move in the wrong direction. That's very bad. What happens if you increase speed? So then you have a high development velocity, but if you don't adjust your direction, then you're likely to miss your target as well. And if you miss your target, and if you still increase speed, what happens? You move away from your target at a higher velocity. That's also very bad. So what we think the best way to approach software development is to have the best approximation velocity is move in batches and small increments, and after each increment, just check whether you worked your way towards your target. And this is basically what the third figure is all about. And then of course, we have to think about productivity, which means different things in different contexts. And there are many, many contexts. What I want to lay out today or depict is the Cynefin framework, and I will show you why this is very important. So you have basically 5 domains. I talk about the 4 domains for auto domains. Counterclockwise, it's the obvious, the complicated, the complex, and the chaotic domain. With the obvious domain, there's a clear relationship between cause and effect, and it's really clear, it's obvious, so probably you also can automate value creation. It's very easy to create value because you know everything about the rules in this domain. In the complicated domain, it's a bit different. You also have a relationship between cause and effect, but it's not clear. So what you have to do, you have to sense or you have to observe, then you have to analyze, and then you can respond or act. Which means value creation cannot be automated any longer, because you have to analyze first. Unfortunately, complicated and obvious domain are domains which we don't see ourselves very often, because we deal with persons, customers, we deal with a lot of uncertainty. So basically, I think we find ourselves in the complex domain. And in the complex domain, how do you create value in the complex domain? You just probe something, experiment, then you go ahead, sense or observe, and then you respond. So you have to have small batches, you have to experiment a lot with A/B tests, multivariate tests, etc. And then you know and you approach your target or your value creation step by step in small batches. And the chaotic domain is also a very interesting domain. If you find yourself in the chaotic domain, productivity is not relevant any longer. You have to do everything to get out of the chaotic domain because you don't have any control any longer. So this is why it's really important to see that the productivity is something which is dependent on what context, or in that case, what domain you are in. And this is, again, the value mapping. And there probably you see or you recognize the Wardley maps. It's defined, or it was defined by Simon Wardley. And we find it highly valuable, and sometimes not with every component and feature, but whenever there's a bigger change in our environment, we apply those Wardley maps, and on the y-axis we have the value chain. On the top, we are really close to customer value. Remember, this means also really close to impact, really close to high productivity. And the lower entities don't mean that they are of lower value, but they're just not as close to the customer as the ones on the top. And on the x-axis, we have functional maturity, genesis in the beginning, so there is no function at all. We have to really create it. We have to concept it from the beginning. Then we have custom-built tools or functions. And then we have products which we can purchase. And on the right hand, there's the commodity. And if we go our way backwards from the customer, we have to start on the top with a user-focused feature. And we see in the value chain what kind of dependencies the user-focused feature has. There are 2 microservices as an example. One of them has a dependency to a semantic graph, which probably you realize this is our federated search service. So this is something which we have to build by ourselves. But then those microservices also depend on PCF, and PCF is a product. And then we go the whole way through the value chain to an IaaS, to the operating system, and to electricity. So what you want to do is, of course, you want to move as many entities to the right as possible. Why is that? Because commodities are much cheaper, are much more mature, and products also are cheaper in most of the cases as opposed to custom-built stuff. And how this relates to PCF in detail is something which Gregor will tell you now.
All right, thank you, Thomas. All right, so let's talk about features in PCF or in microservice or characteristics of microservice architecture that allow us to gain higher productivity. And to start the discussion, I want to show this diagram here, which is a diagram that was shown to us back in early 2016 by Deckel Tankel, which was one of the co-founders of Cloud Foundry. And this is the value line proposition. And we see here, this is an instance of PCF, and this instance is divided by the so-called value line or the business value line. And let's discuss this by starting from the bottom. So at the bottom layer, we have an IaaS, which could be an in-house OpenStack distribution, which could be a public cloud, AWS, Azure, something like that. On top of that, PCF sits. PCF has components like Bosch, which is the automation tool for creating all the internal components like the router, logaggregator, and many other PCF components. Further up the stack, we have a service broker, we have data sources like databases, message queues, etc. And we also have higher level abstractions or higher level services like cloud native services, a service registry, config server, or Histrix dashboard. And everything, all of these components are below the value line, meaning that we as application developers are above the value line, and the value line actually divides both areas. Everything below that area is provided by PCF, and it abstracts it away from us, meaning that although we consume everything below that, we are not necessarily interested in building that, in security, fixing that, in patching that environment, etc. We just assume it's there. We want to consume it on the level above the value line in our applications where we actually build functionality for our customers. All right, what are the specific features that PCF provides to allow for productivity or for increasing productivity? So first of all, when we talk about PCF in this talk, we mean the pivotal application services platform, not so much the container services platform. And the application services platform is an opinionated platform. Opinionated means that it reduces complexity by introducing constraints, but in a positive way. These constraints are assumptions that the platform makes for us, which actually abstracts away complexity and assures a environment or a consistent environment across of our applications. More specific examples for that, how is that achieved, is for instance build packs. Build packs are there to actually containerize applications, so developers can just push their application artifacts and the platform makes sure that it wraps a container image around that and deploys that into the environment. Another thing is that it also, PCF provides by Spring Cloud Services, it provides cloud native components for us, made highly available, like the service discovery or the config server. We don't need to deal with that, it's just there, we consume it. And how are these services provided? There are self-service provisioning or self-service provisioning facilities built into PCF. And these facilities actually provide a mechanism to provision middleware for us. Middleware that our applications want to consume. How is that done? I, as a developer, just go into my space. I have a marketplace there. I can open up the marketplace. And let's say I need to consume a message queue or a database. Right? I actually click that. I want to provision that. The service broker is responsible for provisioning that type of infrastructure, that type of middleware for us. It's provisioned. Once the service broker has completed these operations, the application can simply consume that middleware by binding to it. And with that binding step, it also abstracts away the exchange of credentials and connection information. So I don't have to deal with this sensitive information. It doesn't have to be sent around by emails, etc. It really gets injected into the application automatically using that service binding mechanism. All right, we can see that here in a simplified view at the very bottom. I don't want to discuss it any further, but one thing, we went actually one step further, actually to even remove the burden of managing middleware within our PCF foundation. And it's not a huge burden, but the thing is that every time we introduce new tiles into our platform, we need to maintain backups, we need to patch them, etc. And it also takes more time to actually recreate foundations or patch foundations. And we actually wanted to remove that, and we have started to use the service broker for AWS, where we can actually offload everything that relates to maintaining that middleware, making it highly available, creating backups to AWS. All right, and also some built-in characteristics or features of PCF are for isolation and decoupling of teams. This goes on two levels. So PCF is obviously a application-centric platform, but it's still a container platform. And what does it mean is that it provides process-level isolation for us, meaning that all of our application can run on our virtualized hardware. They can use that resources, and they are isolated from each other without the possibility of interfering. The other level is even more important to us. PCF provides permission-level partitioning, meaning that with orgs and spaces, we can give every product team or every developer his or her specific view on the areas that they have permissions for and they are able to maintain and develop. All right, next thing that is built into PCF are scaling and monitoring. Right? So scaling exists in 3 dimensions in PCF out of the box. There is one dimension which is vertical scaling, right? So you can very easily, by modifying a manifest file or going into the apps manager, you can configure more memory, increase, decrease CPU usage, etc. There is the dimension of horizontal scaling. Obviously, if you want to, you can actually very easily create additional instances of your application or decrease it depending on the load of the application, on your application. And the next dimension of scaling is actually that we are able to scale independently. PCF being a cloud-native platform, it's actually ideal for creating microservice architectures on top of that. And that means that we can actually decompose our functionality into smaller components, into microservices, where each and every microservice can be scaled independently. All right, and regarding monitoring and metrics, what has PCF to offer? Obviously, there is I would call it lightweight tool for monitoring, the apps manager. Me as a developer, I can go into the apps manager, I have the view on my particular applications or my team's applications. I can see if it's running, if it crashes, I can see which logs are currently emitted. I can even restage or restart the applications. On the next level, there is the Historics Breaker dashboard. The Historics Breaker dashboard gives me a view on my microservice and all the other microservices it interacts with. And if that is not enough, if I need to go deeper into troubleshooting, there is PCF Metrics as a tile available for PCF, where I can gain even further insight by looking or searching logs that are retained, I guess, for 2 weeks by default, or looking into the individual metrics of the application for further troubleshooting. All right, so we discussed the features that are available in PCF, and we want to discuss project bootstrapping in our environment, and that is like an extension to the features, or we're utilizing the features to bootstrap projects faster. So what does it mean? So back in 2017, last year at SpringOne, Thomas and I discussed our architecture, how we entered our cloud-native journey, and one of the findings or lessons learned back then was that the time needed for onboarding new teams has been initially underestimated by us. And this goes twofold. There is one thing that back then, lots of our teams were actually not exposed to cloud-native development. We could fix that by creating trainings or onboarding materials, onboarding sessions. But what we meant here is actually the time between when a project is incepted and the time where a team or the product team can actually make the first commit and have it deployed to the integration environment, it took some time. There was a gap between that, and we wanted to address that. Right? So how could we address that? And we found we can address it by standardizing our bootstrapping process and automate it as much as possible. And we're going to discuss how we did that. Here's an overview of how we did that. There's actually two tracks to it. One track is more the infrastructural track on top, and on the bottom, this is what the product teams need to do to actually achieve a first 100% full integration into the environment. All right, so there's a couple of steps. I'm going to go through them really quick. So first, obviously there is a project inception. In that inception, we have a process gateway, which is a manual gateway. Someone needs to sign off on that new project. We define an acronym for that project. We document it. And we actually trigger the next step. In the next step, in our SCM setup, we create repositories for the applications. We create configuration repositories for these applications. And we actually go into configuring the PCF environment for it. What we do here is we create the necessary orgs and spaces, so the development teams or product teams can deploy the applications to. We create a set of service bindings for shared services. In our infrastructure, we have a couple of shared services, like a shared config server, shared service registry, etc. We already provisioned that, so the teams don't have to do it themselves. And we also configure the config repositories that were created in a previous step in our globally available config server. Next step, what we do, we bootstrap the pipelines for deployment or for CI/CD of the application. What we do here is we use the Jenkins seed plugin. It actually creates a multi-branch pipeline for the application code and deployment pipelines for each and every environment. And in the final step from the operations side or from the infrastructure side, we reconfigure our API gateway. We add a default route with some default configuration for it so the application can be exposed to the outside world. And next comes what the product team does. So the product team can, in the meantime, invoke our code generator to create an application skeleton. We are mainly a Java shop, so our applications are mainly Spring Boot applications. So what we do here is the code generator generates a fully working Spring Boot service application. It has a minimal set of dependencies. In the past, we have identified that there was always confusion about which Spring Boot version can I use, which Spring Cloud version do I need to configure, which version of Spring Cloud services, etc. So we already pre-configure that. We pre-configure or generate the manifest files needed, meaning the files that allow the application to be deployed to the target environment. We generate the Jenkins pipelines. We generate, obviously, the Java code along with unit tests. And last but not least, and this is not to be underestimated, we create also the platform-specific configuration. Platform-specific configuration is, security properties that need to be configured. We are changing things like the actuator endpoints, and all of that is also pre-configured with that step. And this is actually the application or the product team actually just needs to invoke the next step, and this is the commit and push. So meaning a simple commit of that generated skeleton will actually be picked up, and if it's pushed, it's picked up by Jenkins, it is built, and if that was pushed to what we call a deployable branch, for instance, master or develop branch, it will be automatically integrated into our dev environment. So at that point, the developers can already access the application through the PCF route or the application or the API gateway. So at that point, we achieved 100% integration. And the overall setup, although there's a lot of steps here that we discussed, but that can be usually achieved in less than a day, I would say. All right, we have some lessons learned regarding that I want to share with you. So one lesson learned is automate as much as possible. It's quite an obvious lesson learned, and I guess you've heard that in many of the talks, and everyone is talking about that. So we want to make it more specific, what we have learned here. So one thing is that we don't expect our developers to use the CF CLI. right? So I hear it in all the time. So people say, oh, it's so easy to say CF push and the application is already there. But actually, to implement a blue-green deployment, you need to script something, you need to do something here, and sometimes it's done wrong. So we want to remove that burden from developers. And we are also offloading the implementation of our pipelines from the developers. And how we do that is that we have implemented a Jenkins shared library where we have all the complexities of CI/CD encoded in there. We are abstracting it away from them, and they can easily consume that in the pipelines where they have very easy made-up steps for that. Everything what we do is as pipeline as a code, meaning everything is co-located with the application repository, so we don't have anyone going into Jenkins and configuring anything manually. Everything resides next to the application. And one thing that we have also learned is that we actually aim for self-contained build definitions. And we had with our colleagues that are also here today, we had some discussions around this. And what does it mean is that we want to achieve that the application repositories has all the external dependencies already in to build the application. Meaning that, sometimes you need a specific version of Maven or you need a specific other tool. And what we say is put that into the application repository so Jenkins or your CI/CD tool can easily pick it up and actually execute everything. That actually releases all the dependencies that you have on your CI/CD. All right, and last but not least, again, lessons learned is that security and automation sometimes collide. These requirements sometimes collide. And what it means is obviously in that process you're dealing with credentials, for instance, the credentials for a Git repository. And these are the places where automation is sometimes more difficult as expected. And this is also what prevented us from getting there or automating everything fully to 100%. We are still working on that. We are evaluating current tools on that. And we hope we will achieve full automation here. All right, which leads us to the conclusion. I think Thomas wanted to share a couple of thoughts.
Yeah, thank you, Gregor. Really quick because we're a bit over time, I think.
All right.
So what is, after all, the most important factor of productivity? We talked about components, services, resources, etc. But there was one thing we didn't lose one word of that, and this is humans. So what we think is that humans are at the core of productivity, and the first value of the Agile Manifesto says it quite clearly: individuals and interactions over processes and tools. And if we think about the research, the scientific research of productive teams, I read, I think, half a year ago, something from Google. They researched what the common characteristics of their most productive teams were, and this was psychological safety. This was the outstanding characteristic for the most productive teams with Google. Psychological safety means that you can speak up in a team, that you can make mistakes within a team, you can ask questions, they might also be dumb in a team, but the team in itself should feel as a coherent organism. And this is, I think, at the basis of everything. So you can have the best tools, you can have the best services, you can have hero people, but if the team itself doesn't give you psychological safety, this is not going to make you highly productive. And this is also a cultural thing, of course, but you can't engineer culture. So the psychological safety has to come within the team. It has to emerge within the team. You cannot apply a top-down approach and tell the team to just apply psychological safety. And with that, we want to close the presentation. Thank you very much for your attention. We're open for questions now.